All right, these were the capacitors that I took out. Now, a lot of people have different opinions about when do you replace capacitors. Just because something is old doesn't mean that you just replace them, or you say, hey, you know, they've lasted this long, they're going to last some. They're going to last some more. Take a look at the brand name. These are Nippon Chemical, right? So these are really, really good capacitors. And so here's one of the capacitors I pulled out. It's marked 220 microfarads. It's a little bit low, but probably within spec. It has a very good ESR, 0.04 ohms. So I would say that capacitor is pretty much fine. Let's grab another one here. Let's see. This is the negative. This is the positive. What's this one measure? It looks good too. Okay, 0.2. And let's take a look at this one. This is a, what is this one? This is a 100 microfarads, 160 volts, 100 microfarads. All right, let's see, here is a 1 microfarad. And he's still measuring a microfarad, 18 ohms. I don't know if that's within spec or not. I need to have a chart of ESR versus microfarads. 18 sounds a bit high, though. I don't know. Anyway, so I didn't really see any capacitors that seemed dodgy. But my philosophy is, if you've taken something apart and it's difficult to take apart, and you're staring at a bunch of capacitors that could potentially go bad, you don't want to have to take it all apart again. So just go ahead and do it if you're there. So I spent 1, 2, 3, 4, 5, 6, maybe 10. I spent maybe, oh gosh, my bill was really, really low though. So some of these were like 17 cents, and some of these I think were maybe 25 cents or something, right? So it wasn't a lot of money. I think when I was at the store and I bought a bunch of stuff, the resistors and the capacitors and everything, I think the bill was somewhere around $4. So, you know, yeah, for $4 you just do everything. You know, why not? And then another thing is that if things then don't work, it's one thing you don't need to go back and look at. You say, okay, I know the capacitors are good because I just replaced them, and you can go look elsewhere. Now, I sort of have a theory of why this board was bad. I didn't put it on camera. It would have been kind of hard to film. I would have had to get out the microscope and everything. I just didn't feel like doing it. But there were lots of cold solder joints. It looked like the board was just wave soldered a little cold in the first place. It looked like a lot of places was just a bit dodgy, and I've resoldered all those parts. But the one that really, really was bad was this connector right here and here. These two connectors were very, very dodgy, and I think they're probably the cause of everything, because they're those connectors that go to the transistor. So I think this is in a bad mechanical spot in the design, and this just flexed and wiggled those connectors and broke them loose. And in breaking them loose, it disconnected the transistor from the circuit. The thing ran away. It probably burned out the chip in the process because it was pumping too much current. And then the resistors melted down and everything else went on. So I'm pretty confident that's what happened to this machine, is that these solder joints probably just failed, and then everything went bad. So, you know, a lot of times, yeah, electronics doesn't fail because of electronics. Electronics fails because of mechanisms, right? Like one of the highest failure rates in everything is fans, because they're mechanical, they spin. So a lot of times the electronics is just fine and dandy, but yeah, motion will kill you.